Okay, this video is going to go through the Honors Algebra 2 Quarter 3 District Assessment Review. Our first two questions are asking us to write the least common multiple of the denominators in each equation and then solve the equation and check for extraneous solutions. So when I look at both of these denominators, I notice that they are all factored, which is kind of nice. So for the first one, I see I have two separate binomials, which means the least common multiple is going to be the product x plus, minus 3 times x plus 2. That's better. And so then for solving, I'm going to create least common, I'm going to use my least common multiple to create common denominators. So this first denominator, the denominator on the right needs an x minus 3. The denominator on the right needs an x plus 2. So now when I distribute, I get 7x plus 14 over x plus 2, x minus 3, equals, distribute the 5x minus 15 over the same denominator, x plus 2, x minus 3. Now at this point, I'm going to drop the denominators because obviously if I have two fractions that are equal to each other and their denominators are equal, then their numerators must be equal also. So I'm just going to go ahead and say 7x plus 14 equals 5x plus 15. I have to think I'm going to, minus 15. I'm going to put the variables on the left side. So I'm going to move this guy. I'm going to put my constants on the right side. And I get 2x equals negative 29. So x must equal negative 29 over 2. And I know my solution works when I go to check for extraneous solutions. The only solution that would be extraneous for letter A, like if I got x equals 3 or I got x equals negative 2, they would make the denominator 0. So that would be a no-go. But I don't have that. I have negative 29 halves, perfectly acceptable. Let's take a look at letter B. Letter B is also factored, so I immediately know that my least common multiple for letter B is just going to be that first denominator, x plus 2x minus 2, because all I got to do then is multiply this fraction by x plus 2, and I have common denominators. Again, the least common multiple of the denominators is another way to say the common denominator. On the left, I have 3x plus 6. I'm going to drop the denominators right away because I know they're the same. And now when I multiply x times x, x times 2, 1 times x, 1 times 2, so I've got 3x plus 6 equals x squared plus 3x plus 2. This is nice because these will subtract off. I'm going to subtract 2 from both sides. I'm going to get 4 equals x squared. We'll take the square root. And we get x equals plus or minus 2. Now, when I go to see if they are extraneous, unfortunately, both of them are, because if I go negative 2 plus 2, that will give me a denominator of 0. Can't divide by 0. If I substitute positive 2 here, I'll get 2 minus 2 times anything also gives me 0. So this gets the x of shame, as I like to say, and there is no solution. Okay, so I want to point out that this is a two-part question. The first part is to state the common multiple, and then the solution. So here are my answers for number 1. Number 2, show the functions are equivalent by dividing g of x and rewriting in the form g of x equals q of x plus r of x over d of x. Now, just as a reminder, q of x is our quotient, r of x is the remainder, d of x is the divisor, and the reason they all have the parentheses x is because they are in terms of x. So we're going to take g of x. I'm going to use long division for the first one. I'll use the box for number 3. And I'm going to divide x plus 3 into 2x plus 7. So the first thing I'm going to do is have a division thought. 2x divided by x is just 2. Multiply back, I get 2x, and then 2 times 3 is 6. I'm going to subtract and bring down. So I'm going to change the signs here. These go away, and 7 minus 6 is 1, and that is my remainder. So I can rewrite this as g of x equals quotient plus remainder over divisor. What are the asymptotes of the graphs? Well, I have a constant here at 2. That tells me that the horizontal asymptote is y equals 2. This denominator is x plus 3. If I were to set this equal to 0, I would get -3. I cannot substitute -3 in, or it will produce a vertical asymptote. So now number 3 is a similar question. I'm going to divide z of x with the box because I did the other one with long division. And this is a really small situation here. I just have x and -4. This box needs to be 5x. This box needs to be -21. This will become 5x. This will become a 5. 5 times -4 is -20. Now, these don't match, so there is going to be a remainder. What is that remainder going to be? That remainder is going to be -1. So I can rewrite z of x as 5 plus -1 over x minus 4. Now, I just want to point out you could also write that as 5 minus 1 over x minus 4. It's really your preference. The asymptotes, the horizontal asymptote is going to be y equals 5 because I have a constant of 5 here. I'm never going to get there, so I'm always subtracting a teeny tiny fraction. And the vertical asymptote, because it's x minus 4, if I set that equal to 0, I will just get 4. Okay, on the next page, we're asked to look at these two graphs and to complete the following below. And the first thing it asks us about these two parent graphs is, are they even, odd, or neither? So I notice immediately that f of x, I'm just going to make a note that this is f of x, is going to be an odd graph. Because it is odd, it's an odd function because it has 180-degree rotational symmetry around the origin. And if you remember, we studied like there's buddy points. So we have this point 1, 1. Over here, we have a point -1, -1. Those are corresponding points on our odd function. When I look at g of x, I notice that g of x is an even function because it is symmetrical around the y-axis. And that makes it an even function. Now, both of these functions have the same domain. They both have a domain of all real numbers, but x is not equal to 0. I cannot substitute 0 into either of these. I cannot divide 1 by 0. I cannot divide 1 by 0 squared. So 0 is a no-go. For the range, now, the function 1 over x produces positive and negative numbers, but it does not produce 0. So the range will be all real numbers, but y cannot equal 0. However, the even function will only produce positive numbers, no negative numbers, and not 0. So we say its range is y is greater than 0. The end behavior on both graphs, on both sides, goes to that horizontal asymptote of 0. So on the left, this is the right. Not that it really matters. The function goes to 0 on both sides for f of x, and g of x also goes to 0 on both the right and the left side. Remember, this is the right side. This is the left side. This is the right side. This is the left side. Both sides go to 0 on both graphs. Number 5 asks us to identify all the discontinuities of this function. Now, let's just remember what discontinuities are. Discontinuities are vertical asymptotes and holes. Okay, if I have a vertical asymptote or a hole, I will have a discontinuity. Horizontal asymptotes are not discontinuities. The first thing I'm going to do to find them is factor the denominator, because I notice I've got x squared minus 25 can become x plus 5, x minus 5. I'm going to purposefully switch my pen color. Oh, pink's nice. And I notice that this x plus 5 divides out. That immediately produces a hole. Okay, this will produce a hole at x equals -5. The factor that divides off, if you set this factor equal to 0, you get -5, so that is our hole. Then what we're going to do is we are going to look at what I like to call the compressed function. That is not an official term. I just needed a phrase for the stuff that is left after you divide, and this is our compressed function. If I substitute -5 in for x on this compressed function, I get -1/10. That will be the y value for the whole. I'll just write them up here. So we've got -5, -1/10. That's the whole. Now, the factor that didn't cancel, the x minus 5, this produces a vertical asymptote. So if I just set that equal to 0, I get x equals 5 is the vertical asymptote. So those are my two discontinuities. I have a vertical asymptote at 5, and I have a hole at -5, -1/10. That was a bottom. Yep. On the next page, we're being asked to sketch some polynomial functions. The first sketch we're being asked, we need to have a positive leading coefficient. It has an x-intercept at 5. Actually, all of these have an x-intercept at 5, so I'm going to be like 1, 2, 3, 4, 5 point. 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 Okay, took care of that. Now here, the leading coefficient is positive. Notice it doesn't say if the degree is even or odd. I just know I've got M behavior on the right, it goes up. So I know from this x-intercept, it goes up. Now, I don't know if this x-intercept is a double, is a triple. I don't know. So I'm going to just kind of go with it. I know the leading coefficient is positive. So I have two choices. I guess if it was an odd function, it would just go like that. Doesn't say anything about the degree. Hold on a second. Let me just think about this. Okay, so I guess that works. Leading coefficient is positive. This would be for an odd degree. Just as a note, like you could make it an even degree and like swoop it up, and that would be good too. We'll just kind of do it both situations if there's more than one situation. Okay, so for the next one, we also have a right M behavior going up, but we have a negative leading coefficient. So if the right goes up and it's negative, this one doesn't work. We're gonna have to scratch this problem. You can't do this. This one is not gonna work. Because if the we're gonna scratch this one. So that's not gonna work. My bad. I should have proofread this. Let's check this one. Positive leading coefficient, and it goes down. Yeah, this one's not gonna work either, because if it's odd, it would look like this. If it's even, it would look like this. That's not one's not gonna work. I hope this one works. Let's see. Leading coefficient is negative. Yep, that'll work both ways. It can go down, or we can look like this. So I apologize. That's why I should probably make an answer key before I start making the video. I just kind of, you can tell I copied and pasted, so that was my bad. These are not possible. Whoopsie doopsie. Happens. Okay, we got two more sets. We've got some properties, and then we've got some division. We've got this really nice graph, and we're going to state all the properties. I'm going to start by highlighting the increasing and decreasing intervals. I'm going to highlight the increasing intervals in yellow and the decreasing intervals in green. And I notice as I start my graph and I move down, it's decreasing. And then after that point, it switches to increasing. And then it switches to decreasing. And then again, it switches to increasing. So I'm going to start by writing these two yellow intervals. The two yellow intervals, the first one is between two values. It's between -3 point decimal and 0.5. I'm going to go 3 decimal points. That's a lot of writing. So I'm going to say -3.72. That 7 tells me to round it up. So 725 is less than x is less than -0.508. That's the first one. And then the second is after 1.9. So I'm going to have x is greater than 1.983 because it's like there's a 5 here, so I'm going to bump it up. And again, then greater than sign, if you forget that it's bigger than 1.9, we can always look on the x-axis for that little trick. Now, the first decreasing interval occurs when x is less than -3.725. And the second one is between -0.508 and 1.983. End behavior, both of these go up. So on the right, as x goes to infinity, y goes to infinity. You can use f of x. The R and L are optional, but I need them because I'm right from the left. On the left, it also goes up. Local minimums, I've got 2 local minimum values, and I'm going to only write down the y values. My local minimums are -0.5. Whoops, I forgot to put in the wrong spot. -5.0.704, which is this guy. And then here's the other one. And I have a local maximum at 3.394, because after that, 3 is an 8. Cool. Okay, some division. So I've got 4 division problems here, and it says divide each, write your answers in the form Q plus R over D. So I'm going to do the first, I'm going to alternate my method. I'm going to start with long division. I've got x minus 4. And this is a reminder that you are allowed to use a little 4 function or a little scientific, but not your graphing calculator if you need it for the arithmetic. So the first thing I'm going to do for letter A, I'm using long division, is I'm going to have a division thought, which is x cubed divided by x is x squared. Multiply back. Subtract and bring down. Gives me 9x squared. I'm going to have a division thought. I'm going to multiply back. I'm going to subtract and bring down. Well, that's going to be 4x, drop my 7. Have the division thought. Multiply back. Subtract and bring down. Now I have a remainder here. That remainder is going to be 9. So my answer will be x squared plus 9x plus 4 with a remainder of 9 over x minus 4. There's A. Letter B, I'll use the box method. Not blue though, because that's not good. There it is. So many little logs. Okay, so this is going to be blue. x minus 7. This corner will be x cubed. This corner will be negative 13x squared. This is crooked, but who cares? 40x, and then this is going to be 18. I want to remind you, please do not just drop that 18 in that bottom right-hand box, because we don't know. Maybe there's a remainder. X cubed, what times x is x cubed is x squared. Multiply back. That needs to be a 6. I almost said 5. That would have been bad. Yeah, that's 13. So then this is going to be minus 6x, and that's going to be 42x. That's going to be a 2x. That's going to be a 2. That's going to be negative 14. Now 18 minus negative 14. I feel like I messed something up here. It's kind of big. Let me double check. Let's double check. Okay. Oh, I found it. This should have been a minus 2. So this could become plus, and then it's just 2. So now we've got x squared minus 6x minus 2 with a remainder of 2 over x minus 7. I'll do letter C with long division, and then I'll do letter D with box. So letter C, first off, I'm immediately noticing that both C and D, when I do my power check, they fail the power checks. This is 3, no, this one's good. 3, 2, 1, yep. But this is a no, I am missing all kind of things. I'm missing a 0 x cubed. I am missing a 0 x squared. This one's okay. 3, 2, 1 constant. That one's good. So I've got x plus 2. So now we've got x squared. And because x squared cubed divided by x is x squared, multiply back. I'm going to go this one. I'm going to talk all the way through it. X squared, subtract, apparently I am. Just double check my arithmetic. Yeah, it looks good. When I get a number like 13, I'm like, I'm sure that's 13, but no, it is. So now 13 is going to be 13. X minus 26. Subtract. And that's a 30. That's, I checked my arithmetic. That's just a bigger a remainder. That's okay. You can have a big remainder. Plus 5x minus 13 plus 30 divided by x plus 2. One more. Now, I gotta make sure I got all my zeros here. I don't want to mess it up. So I'm dividing x minus 3. Oh, man. So this is going to be negative 4x to the 4th. Okay, now I have no x cubes. I have no x squareds. Oops, I missed one. I have 11x. I did not space this well. 11x, and then I have minus 7. Okay, here we go. This is going to be negative 4x cubed. This is going to be 12x cubed. And to make it a 0, I need to do negative 12x cubed. Negative 12x squared, 36. This is gigantic. Squared. This needs to be a negative 36x squared. This is going to be negative 36x. This is going to be 30 times 3 is 90. 6 times 3 is 18. So this is going to be 108x. Hot damn. That's an 11. 108 minus 11. Well, 108 minus 8 is 100, and there's 3 more, so 97. Oh, Lord. This is going to be a 9. This is going to be. Wait, this was negative. Oh, poop. Oh, no, that just means negative 97. That makes life easy. No, that's not right. Something happened. What did I do? Mm-hmm. 30 times 3 is 90. 6 times 3 is 18. Add them together, it's negative 108. This needs to be hold on. I'm gonna double check my pick. I'm gonna go grab a calculator and just double check it. Because I don't want to have to do this problem twice. I found my stupidity. A negative times a negative is a positive. Okay. Sorry about that. I knew I had to have had a little arithmetic mistake. It's hard to find them. All right, so now this is going to be a negative 97, and this is going to be negative 97, and then 97 times 3 is, well, 9 times 3 is, and then 3 times 7 is 21. And they're both negative, so don't be stupid. This one's going to be positive, 291. And so now I've got negative 7 minus 291. And I actually have, went and got my calculator when I paused and I double check it, so I'm good to go on this. It's just a lot. We've got negative 4x cubed minus 12x squared minus 36x minus 97. You can either do minus and then like you can go, come on. You can go minus and then 298 over x minus 3, or you can go plus negative 298 over x minus 3. I hope that was helpful. I'm sorry about the mistakes on number 6, but on the plus side, less work.